Okay, so welcome back. We're in 12.3, and we've learned some vocab words. We've learned what a chord is, that the diameter is the biggest chord in a circle. We also learned that if the chords are the same, then the distance from the center is the same. The arcs are the same. If you have a perpendicular, the diameter is a perpendicular bisector to the chord, then it forms a right angle. The radius will always be the hypotenuse. So these are all things that we're supposed to know already. We now start talking about a new concept called inscribed angles. Now, I like to use a rubber band to try and explain this one, but here we are. Inscribed angle. Okay, so we've talked about central angles, which are here. Okay, now notice the angle, whatever the central angle is, this angle and the measure of this arc are the same. Now, this work gets confusing, and one of the skills or the processes you may want to use is start by drawing a circle and then marking what the arcs are. So like putting the points where the lines touch. Then going around and seeing if you have a diameter. Okay, so one, you want to draw the circle and mark the arcs. Okay, and you want to mark the arcs, okay, with points. Okay, so like this, you're going to put points wherever the lines touch the circle. Now, the reason you're doing this is because you're going to draw one thing at a time and find the measurement. Okay. Then two, you want to see if they give you a diameter. Now, what information is going to be important about a diameter? Hopefully you know that that tells you pieces of the circle are cut into 180 degrees. So you're going to use that measurement of 180 degrees to find the missing pieces. So for example, if you knew this arc was 60 degrees, well, there's the diameter, it's 180, so that means this measurement over here has to be 120 degrees. So this is how this section evolves. You're trying to find bits and pieces and putting things together, and okay, this goes there, and this goes up to 180, and so on and so forth. You want to start with a generic picture, though, with no angles in it. Then you'll want to draw one angle at a time. And when you draw one angle at a time, then you can use what we're going to learn. We haven't learned it yet. Then you can use what we're going to learn to find the missing angle or to work backwards and find the missing arc. Okay? Now the central angle is easy. The angles and arcs are the same. So that means this angle would also be 60 degrees and this angle would be 120. Okay? Because central angles and their arcs are identical. Okay? All right. So now we talk about inscribed. Okay, inscribed. And an inscribed angle is an angle that the vertex touches the circle. Okay, so a central angle is where the vertex touches the center, obviously. An inscribed angle is where it touches, the vertex touches a side. So if I was going to do a math problem, I would draw this one, and I'd put 3 dots on my paper because it's cut into 3 arcs, even though there's only one angle there. There's an arc here, there's an arc here, and an arc here. 1, 2, 3. And you know all 3 of those arcs will add up to what number? Correct, 360 degrees. So this is why it's important to take it piece by piece. So when you would go to redraw it, if you were doing a problem, you would draw the circle, and you would just put those 3 dots on there. And then you'd start piecing it together. All right, so this arc is still 60 degrees. Okay, I'm matching it with this picture. I'm going to use a rubber band to explain this. Okay, so if you look at this, we'll say that this is my angle. Okay, so everybody sees that's my angle. And we're going to pretend like that's the distance from the circle to the radius. Now, I'll draw a bigger picture so this makes a little bit more sense to everybody, because this is kind of interesting. So I'm going to draw the big picture. I'm going to let you see how this works. Okay? There's a circle, right? And I'm going to put this as the center. All right. So here we go. This would be my angle, arc, okay? Now watch what happens. Finger there, finger there. There's my central angle, okay? Everybody can see where my central angle is, right? You see it? Now, when I take that, what happens to my angle as I move further away? I put it over here now. What happened to that angle? It's there. This is it here. Then I move it out. What happens to the angle? Does it get bigger or smaller? So I'm going to do this. Okay, we'll put that there. And I'm going to mark that angle like this. Okay, so everybody sees that angle. Right? There it is. Now I'm going to move it to here. And you see that angle, okay? Is it bigger or smaller? Well, I'm going to try and do this with one hand and put the measurement on there. See if I can do it. Okay, is it bigger or smaller? Hopefully you notice that angle is smaller, right? So the inscribed angle is smaller than the central angle. So here we go. Notice where I'm touching is still the same spot. My two fingers here are touching the same spot. Inscribed angle. Touching the circle. Okay? Now I know that one's smaller. So let's try to understand conceptually what's happening. When I go to the center, that's one radius. That's why the central angle and arc are the same. That's one radius. When I go to the other part of the circle, I've now taken that radius and multiplied it by what? 2. So I've doubled the distance, which will have an inverse effect on the arc. In other words, the inscribed angle becomes how much of the original angle? Please, remember, it's getting smaller. Correct. It becomes half. So every inscribed angle is half of its arc. So that means if this was 60 degrees, this would be 60. Okay, we've already established that. But this would be 30. Okay? So the inscribed angle is half of the arc. And conversely, if I have the angle, I multiply it by 2, and I get the arc. And the arc and the central angle are the same. So you got to be able to work forward, backwards, backwards, forwards, forwards, backwards, backwards, forwards. Okay, so let's look at our work. Okay. All right, so here we have a picture, and that's an inscribed angle. And we just said, what would the measure of this angle be? That inscribed angle would be 30 degrees. Okay. This is called an arc. But because it's cut, it's relating to the angle, it's called the intercepted arc. Okay? It's called the intercepted arc. The reason it's called the intercepted arc is because they're telling you it is the corresponding. Right? We used corresponding before matching. The problem is this doesn't correspond because it doesn't match. This corresponds. 60 corresponds with 60. They are matching. This is the intercepted because they're related, but they're not matching. It's the intercepted arc. So that means this angle eats the arc. When you eat something, it gets smaller. When you puke it, it gets bigger. Okay? However you want to remember it. I know the number is always 2. So when I look at this, I go, oh, well, I ate something, so it's half. Oh, Pac-Man, I threw it up, so it's double. Now here, it's the same. So you got to be able to visually identify the central angle and an inscribed angle. Okay? The vocab is the hard part. All right. Now, it doesn't matter where I were to move on that circle. Like, if I took that rubber band and moved it around, so I'll just put the rubber band here. Okay? It doesn't matter if I go up here. It doesn't matter where I go on that circle. That angle will always be half, which is the kind of neat thing. That's why I use the rubber band. That angle, as long as I'm moving on the circle, will stay the same, no matter where I move it. Okay? As long as it stays on the circle. So I'm always paying attention to where it connects. If I pay attention to where it connects, then wherever it moves, it doesn't make a difference. So like right here, if I were to connect it here, see that inscribed angle? That's still 30 degrees. Why? Because it's still this arc. This is an inscribed angle. It's still half. Just because I move it around the picture doesn't make it any different. All of these angles eat this arc. They're all going to be 30 degrees, every one of them. All right? Okay, so you can see when you look at this picture, wow, that's really confusing. But if you started it like this, put all the dots where it touches, and you knew this was 60, then as you draw one at a time, okay, that's 30. Oh, it's eating the same thing. That's 30. That's 30. You can draw them one at a time and get the measurements. All right? That's why I tell you to do it that way. It's not because Mr. Frazier's always right. I just want you to understand I do it that way because it makes it easier for you to see the problem. All right. So we're going to look at an actual question. Okay? We'll do got it 1. Okay. And then I'll put the answer up when we come back. We'll talk about it. All right, now we're going to continue with the second type of problem. The second type of problem is understanding that if you have a right angle, if your inscribed angle is a right angle, so let's just say I go ahead and do this, and I draw the inscribed angle. If that angle is a right angle, what does this line segment have to be? And hopefully you've already said it. If this is a right angle and it's inscribed, that means this line segment, if I were to draw it, that means this is something you got to draw, or if you drew it, if drawn, this piece would be the correct diameter. So this is what I mean by trying to find the diameter. Well, what makes that interesting? That's because this would be 180 degrees. Look at that. And the inscribed angle would be 90. So this would be 180, and that's 90. Okay? So again, visualization of what you're going to do, and then do it piece by piece. All right. So I'm going to do problem 2 right on here, even though they've already done it, and I'm going to show you what I mean by piece by piece. So they want to know what is the measure of the numbered angle. So what do I start? I draw my circle. This is from problem 2. And I see that there's a point there. There's a point here, and there's a point here. I know that this arc is 40 degrees. I always start with the arcs. This measurement is 70 degrees. Okay? And then there's a point over here. I know that this piece is a diameter, so I draw it first. Why? Because the diameter is important. It cuts it into 180 and 180. Now, most of you can already see I can put in all my arc measurements. I know this is 70, so this has to be 110. This is 40, so this has to be 140. Okay, pretty easy math. Now, will I always need all those measurements? Maybe not, but it's like a puzzle. If I can find the outside pieces first, let me find them all the ones that I can find. Then draw one angle at a time. And the angle they want me to draw is right here. They want me to draw this angle. So how much does that angle eat? It eats all 180. So if it eats all the 180, that means this angle has to be 90 degrees. Okay? And again, if you start by drawing the whole picture and then chew it apart, put in the arc measurements first that you know, then draw one angle at a time. Now, this is what I mean by mark the arcs. So I mark the arcs and I put the arc measurements of the ones I know. When I do one angle at a time, which angle do you think I should always start with? Yes, you should start with the ones they give you measurements for. If they give you the measurement of the angle, you draw that angle and find the measurement of the arc, because it might help you find other arcs. Then you start drawing the angle that they're looking for. Okay, so we'll do problem B as well, and then you'll do got it too, and we'll check it again tomorrow when we come to class. Okay, remember this is from 814, page 814 and page 815. All right, so now I'm going to do the B one. Again, I'm doing it even though it's an example problem that's in the book, so you can see how I approach it one piece at a time. So there's my circle. I mark the arcs. So I know it touches there, there, and I know it touches there and there. It touches 4 times. And they give me this arc measurement of 70 degrees. Now when I look at that picture, there is no diameter, so that's not going to help me. Then I draw one angle at a time. The angle I'm picking is the 38 degrees. So I draw that one. It's 38. Okay. Can I get any other arcs? Yes, I can. So now that 38 is, I'm throwing it up, it's now 76, right? Because I double it. Okay? Now, I've put all the information that I can from the picture. There's no diameter. I can't subtract from 180. I've got all the arcs I can do. Now I'm going to draw the angle they want me to find. They want me to find angle 2. And you'll see that angle 2 swallows 76, which means angle 2 has to be 38. Why? Well, they're eating the same arc. Both those angles eat the same arc. They're going to have the same angle measurement. All right? Okay, you do got it number 2, and like I said, we'll check them in class for the correct answer. This is inscribed angles. All right, good luck. Remember to write down any questions you might have.